everyone. It's really nice to be here and actually meet in person so many of the people that I basically only knew from GitHub. So it's really great. I'll tell you this. I'll try to share my experiences testing mobile games, mostly ones developed in Unity, and how I managed to do that using Appium. First, a little bit about myself. I kind of identify as a software tester. I've been a tester since 2002, and I think for the majority of my career, I tested mobile apps or devices or something related to mobile. Basically, my first job was testing mobile apps before I even owned a mobile phone. So it took still 2 years before I bought my own. So I've been doing a lot of mobile testing and lately mobile automation and also some mobile app development. I work at Altom. I'm actually one of the founding members at Altom. We're a company from Romania. That's where I'm originally from, but we also have an office in Finland, in Helsinki, where I've been living now for over 12 years, I guess. So the stories that I'll share today are mostly related to 3 main things that I've been working on lately. First, I worked on quite a few projects with Bitbar. Bitbar is a company from Helsinki originally. They developed Testdroid Cloud, which is the service that kind of gives you access to many devices in the cloud, both iOS and Android. And they let you kind of use those devices either for exploratory testing or for running automation on them. I started working with them trying to help their clients that were running tests on Testdroid Cloud develop better tests for their mobile games, mostly for the mobile games side of their clients. I'm currently also working on a totally different project with a company where I'm part of their design and new concepts team. We have a very, very small software development team that kind of tries to implement all of the new concepts that the team comes up with. We implement the software side, and we need to kind of come up with apps very, very fast, be able to try new designs very fast, and kind of deploy those and support as many platforms as possible, from iOS and Android to any desktop or even like a Samsung TV with some, I don't remember their OS name. So this is why we kind of decided to use Unity for the developing these apps, even though it's non-conventional to use Unity, which is essentially a game engine for mobile app development. But I've been working on that quite a lot now for this kind of fast prototyping, and I've kind of moved from only testing those apps to also developing them. So I started getting a lot of experience developing apps in Unity. And then the third thing is something that's been ongoing for quite a while. I have quite a few projects with a couple of friends developing some, let's call them hobby games projects using Unity. So I want to try to talk a little bit about what I think is special about mobile games and testing mobile games and trying to the problems that you have with them, mostly in comparison with just basic mobile apps that I think we're all used to. I think you've all seen probably these 2 pictures before. It's a major problem in general with testing mobile apps, the fragmentation issue. The one on the right or left, that one. That's actually from 2015 from OpenSignal. They haven't published newer ones, but I think the situation is maybe a bit better, but not much better. Every little square there represents a different Android device. And the difference between some of the high-end models of Android phones and some of the lower ends is so big. The fragmentation there is so significant that you sometimes cannot even call them the same platform. They become 2 different devices that you need to support sometimes in very different ways. And the other picture is from last year, the most common screen resolutions for mobiles. Again, for games, this is very important because the real estate of the screen is very important, can determine how well or how difficult it is to play the game on a mobile device. When I kind of joined Bitbar and started working with them, their customers were what they were trying to do was to deal with this fragmentation issue that they have on the mobile side. And typically, I think there are two main reasons why mobile games are special compared to mobile apps. One of them is the fact that if you want your game to be available globally, which you most likely do, there are so many, you cannot just pick the most common combinations of devices that are in use for your game. You have such big differences between an Asian market to a European market that if you try to kind of take all of them into account, you still end up with hundreds of models. So it's not like you can say, okay, I'll choose these 5 and focus on those. And I think for mobile apps, maybe usually your audience is more targeted. You're usually offering a service in a specific country or to a specific type of users and so on. So maybe you don't have to deal with kind of the entire world altogether. And the other problem with mobile games in general is that a lot of your users are going to be teenagers and kids, and a lot of them are not going to have the latest models. They're going to have like the hand-me-down device from the parents that gets the latest model, and then they get some low-end or mid-range device that they still try to play all the games on. So for games, you cannot just ignore the low-end devices. They might be even a very important part of your target market. So because of this, I think there will at least, I mean, Finland is also nowadays a very kind of like a popular place for developing mobile games because there's been quite a few successful companies from there doing that. So there's a big industry growing there for mobile games. So in Testdroid Cloud, there were a lot of companies that were trying to just develop a set of very basic tests that would just maybe install the game on iOS and Android on as many devices as possible and try to launch the game, see that it loads okay, it doesn't crash, it doesn't run out of memory. You could play the first few steps of the game and you could maybe walk through the menus to see that everything is okay. So something very, very basic that they were trying to kind of cover on a lot of devices. When I joined, I think the choice was already made for Appium because there's been quite a few talks already kind of identifying why Appium is a good choice. That I also found would apply to the context of mobile games. Because it's cross-platform, it's really good at interacting with the device, and this is what most of the customers were trying to do. Just install the app, start it, maybe change some settings, maybe something, but very basic things. Of course, because it has the many programming languages and so on. Also, Testdroid Cloud supports Appium quite nicely. I think many of the other device cloud platforms also support Appium. So it's a very natural choice for the kind of test that they were trying to do. The problem there is that there's also a problem with using Appium for games in general, and that kind of takes us to what's special about Unity as a game engine. I take Unity because this is what I have experience with, but I think it's basically almost exactly the same, the situation with other game engines like Unreal. I just haven't used Unreal myself. I have this example that I'm going to use throughout the presentation a couple of times. This is one of Unity's sample games. They use it as a tutorial for a 3D adventure game. This is a basic level in Unity. This is how it looks in the Unity editor. This is the security room level where you have a player, the woman there in red, you have the guard that's guarding the gate there with the laser grid, and you have a picture there that you can interact with. And on the left side, you see all of the elements that you have in the game and all of the elements that you could, in theory, interact with. And the moment so Unity can then, using this one level, you can build it and export it as an APK or an IPA and run it on a mobile platform. I have here an example of how the same game, the same level looks on the Appium Inspector. This is very similar to the good old problem of trying to test Flash applications with Selenium. You see one single view, one canvas that has everything painted inside it. So while it's very easy to start the game and see that it's loaded, it's very difficult to do anything else inside it. All of those elements that you'd want to interact with are not exposed as native through the native API, so you can't really see them or interact with them with Appium. And this obviously caused quite a lot of challenges for the clients that were trying to test their games. And I think like a lot of us have tried, I'm sure everyone in this room, if they've ever tried something, they've probably tried just clicking at coordinates. I also think that everyone knows why that's just not a good idea. Also, when you think about the fact that they were trying to deal with mobile phones that have different resolutions, this was one of the main problems. You can't really guess, even if you... I mean, we've seen very, very sophisticated ways of trying to calculate based on the scale of the screen where the certain point would be. And even if you manage to do that, you still don't have any way to assert on anything that's on the screen. That's maybe an even bigger problem. So when I started working with Bitbar, we started working on the idea of adding image recognition to existing Appium scripts to kind of help. First of all, I mean, clicking at coordinates is great if you know the right coordinates, and with image recognition you could find the exact point where you would have to click. And then, of course, you could also assert that certain elements are on the screen displayed in the way that you want them to. And what we tried to go for was something that was, we didn't really want pixel-perfect matches. This was, again, because of different screen resolutions and different, even like in a 3D game, you have different angles for the same object. This was not going to work. So we used OpenCV, which is kind of the de facto choice when you're trying to do image recognition, at least nowadays. And we used feature detection and matching algorithms, which instead of trying to match pixel by pixel, they try to find the features of the image that you're searching for in the bigger picture and then make assumptions about where the image that you're searching for most likely is. So in this case here, this is the famous example for feature detection. You have the cookie box. Even though it's in like not even, it's totally tilted at a different angle and a little bit under the rice box there, because there's enough features that match between the two pictures, the algorithm can make an assumption and say, okay, the green square there must be where the original image is, and it's close enough, or it's at least close enough for you to click in the middle of it if you're trying to do image recognition with on a mobile screen. So even though you don't have an element model or an object model from Unity, you can kind of create your own mobile elements using this, like a set of these query images that you'd define in your game using one resolution and then try to identify and find on screen on any other resolution. I have here an example of, the algorithm that we used is an open source version of the many choices that OpenCV has. It was called Akaze, which had all the kind of the properties that we were looking for. It was resolution agnostic and worked at different angles and so on. This is an example from The Sims, the mobile version, the previous mobile version of The Sims. If you define your house, your main house in The Sims, like we have the smaller picture over there, this is the exact screenshot that it was taken from. So, of course, it's a perfect match. It knows exactly where that image is, but it's going to find it even if you zoom in or out, even if you turn it, and even if you have it at a completely different zoom level. And this is, in theory, this is very, very different from what you started, but it's still going to have enough matches for the image to know that it's probably there. So this was really, really nice. It really improved the scripts for many of the customers. This is like an example from the Testdroid Cloud, with one game, another sample game that's running on one device and the report that you have in the cloud. And in the cloud, you'd even see, it's maybe difficult to see on those screenshots, you'd see even, but here you can see where a specific element was found, because you can see the green square around the More button there. So we kind of worked with this on quite a lot of quite a lot of clients, some of them bigger, some of them smaller, trying to get them to write very simple scenarios. This is what they were looking for, and it worked really, really well for that. Some version of whatever the framework that we built is available on GitHub, on the Testdroid samples repository, on the Bitbars GitHub account. So you can, if you want, you could try it and see how it works in real life. One of the best things about this was that using it and writing Appium tests for such games required absolutely no changes to the game itself. The two examples that I have, this hill climb racing and then the Sims, we never really worked with them. I could just take the APK from the Google Play Store and test with it and run these tests, because it really requires no changes whatsoever. You just take screenshots from the device and tap using Appium at specific coordinates. So this was very good. It really found a lot of issues, things like out of memory or crashes, a lot of course, the graphics, the display issues, which this is really good at. But of course, now comes also the downside of trying to use image recognition. The most common one is it's not fast enough. And this is still I don't know, maybe eventually we could have improved the algorithm, but for games like The Sims, where it's very action-driven, that works well. You need to do something before you assert something, so the speed was not necessarily an issue. But if we wanted to automate something like an endless runner, where you need to react very fast, by the time you took the screenshot and analyzed it and tried to verify where something was on the screen, it would be too late. The thing was already gone, and it just wouldn't work at all like that. Of course, it didn't work for apps that had a lot of text, or like games that had that. It only works well when you have a game that's very graphics rich. And it didn't give enough granularity. You couldn't really. So if we look again at the example, this example, it's not sure if this is a good thing that the house is still a match. The sim is not even in the house anymore. You don't have that level of granularity. Of course, you could set some parameters as to how strict you want the matching to be and so on, but if you went too far, then it wouldn't find them because they were simply at a different angle. So it couldn't really work for anything more complex than the basic scenarios where you're looking for something to appear, and when it does, well, that's it, it's good. But because of these reasons, at least the moment I started working on also developing apps with Unity that had a lot of text, and where text was basically the driver for navigating the application, and then when I started developing my own games and trying to kind of do more than just do also some like functional automated tests or cover more grounds, I had to think of a way to kind of go beyond image recognition. And going back to this example, what I really needed was access to all of those elements there on the left. This is what you really want to have. And I attended a meetup in Helsinki. Unity has a office in Helsinki. They don't do the game engine development there, but they have quite a few people that are knowledgeable about their projects in general. So one of the guys working there told me that they have on their GitHub, on Unity's GitHub account, they have an example of an implementation they did for a hackathon of using Appium to interact with elements that a Unity game can just kind of spam in the device logs. So you'd kind of add some elements there in the scene. You would enable something that would give you information about all of the elements here that you are interested in. You could say you're interested in the player, in the guard, and in the picture. And this component would all the time log to the device logs. This element is present, it's at this coordinates, it has this text, and so on. So you could do that every second. And then they also had some example of how from Appium they could then parse those logs and get the coordinates and do all of the actions like they would with Appium. And I thought that was great. It was a very simple example. I tried it, it worked quite well, but it was still a bit too slow in the sense that it wasn't real time. If you move the player, by the time you parse the logs to see where the player is, the player had already moved just enough to the right to miss it when you try to click on it. So then I started thinking about developing with the same idea of kind of adding something to the scene in Unity, adding a component or enabling something special. The moment you have something in your scene like that element has all the information it needs about everything, all the components that are in that scene. So I started working on a component that we now call Alt Unity Tester, that would open a socket connection on the device. You'd add that component, it would open a socket connection, and it would wait for commands on a specific port. And using that, this is a drawing of how that works now. So you would kind of just enable let's say the Unity tester in your game that would listen on port 1300 there, and from your Appium tests, you'd kind of create a second driver, we call it Alt Driver, that connects on that port on a TCP socket connection, and it can send commands. It can, for example, say what's the current scene that is loaded, what's the current level, and the component here would look and say, okay, the current level is home, so it would send that as a JSON back to the Appium scripts. And from there, you could find an element, you would get the coordinates, you could get information about it, more than just the coordinates, but maybe if it has any properties, anything that you are interested in. And then the action of tapping on the element is still done through Appium when you know the right coordinates. And it's pretty much real time, so it worked great for all of the interactions that I've used so far. I didn't see a delay that would affect my tests in that sense. I have an example here with the same game. So these would be the elements that I was trying to interact with: the player, the guard. There's the message canvas whenever the player goes to the guard. Here it's hard to see, but there's a text field there that would give you. The guard would say, get lost, because you don't have the right information that he needs to let you pass. And this is an example of what we wrote so far for the Python bindings. So we have the socket connection running in the game. We also need something on the client side to kind of open or create the alt driver and communicate and send commands and expect the replies. This is an example of how you'd wait for the scene to be the one that you want, the security room. You'd wait for the player to get there. And then once you tap on the guard, you would wait for the text below to be get lost before you say, okay, I could interact with the guard and the test has passed. We have, for the Python bindings, we have quite a few methods implemented already. Of course, we can find elements, wait for them, find elements with the text, and so on, all of that. You can wait for elements to not be present. And you can get information about the level that is currently loaded. But then we also added kind of some actions that you can do on the alt elements that you find, so basically the translation of the elements from Unity that we were trying to get. All of these are done with Appium, all of these interactions. And we've done it so that, of course, you can tap, but you can also get specific properties as long as they're public. You can, in Unity, you can get their values, you can set their values if you have a public method for setting them. And then you can even call a specific component method with the parameters that it needs, which means that in theory, you could perform most of the actions also straight from Unity if they're more complicated than a tap, or if you want to invoke the player to maybe it has a special action that it does in a specific case, then you could call that method directly from the Python scripts. Here's the same game running in Testdroid Cloud. We found that it's very very simple to get the test running because it's still just Appium. You build your APK or IPA. All you need to do is forward the TCP port, everything, the communication between that port that's on the device to the local machine. At least in Testdroid Cloud, you get access to basically like a container where you can actually access ADB and if you want to, and forward the traffic and so on. So you have a lot of freedom into setting up your tests. So it was very easy to get these running there and get the same results that I would locally. And of course, it would be the same on a continuous integration server. All you'd need to do is forward the port information from the device to the local machine where the scripts are running. Or of course, you could connect to it over Wi-Fi. As long as you know the IP of the device, then you could connect to it directly on that IPN port. We open source this, so it's on our GitLab account, not GitHub, GitLab. And we decided to make it open source not long ago, so it's quite new, but we already have some feedback, a few issues, so I'm happy to see that people are trying it out. We want to add, of course, we need to add more bindings. We just have a Python now, so I think Java is going to be the next thing to add. And we were really thinking about implementing maybe like an actual, some form of a Unity Appium Driver. This is now, it feels like a two-step process. And then at least implement an inspector so that people don't need to necessarily be in Unity Editor to see the elements and try to identify them and so on. They could just do that from Appium Inspector. So I've been using this one now very, very happily, and it has helped me really quite a lot in my day-to-day work. But of course, if I'm trying to draw a conclusion, which one is better, which approach is better between image recognition and this one requires actual changes to your game. We've now wrote it so that it only by default works if it's development builds that you're running, so that you don't start that socket connection on your production game. But still, you need to make a specific change to the game, and you can't just. I've at least in working with Bitbar and with a lot of companies, we've heard that a lot of testers do not have access to the code, do not necessarily discuss with the developers. This is not ideal, but it's apparently a reality. So for those kinds of situations, you couldn't use the Alt Unity tester. The image recognition solution, though, worked. It didn't matter what it doesn't even need to be Unity. The Alt Unity tester only works for Unity. The image recognition works in every case. And as long as your tests are simple enough, this is an excellent way to get started and have something that runs on cover a lot of ground with testing on as many devices as you want. I don't know if we have time for questions. Yeah, I'm here for the rest of the conference, so thank you.